Okay, let's get started. Okay, let's get started. How's the audio in the back? That seems loud. Okay, so we're going to talk about cognitive development. The last topic in the sequence. So here are the topics that we'll cover today. We'll talk about the fundamental contributions of Jean Piaget to the field of developmental psychology. Talk about theory of mind, the idea that you can think about what other people think. And as it turns out, young children are limited in terms of their theory of mind capabilities. They can't quite put themselves in other people's shoes and reason from their perspective. Then we'll discuss some of the challenges to Piaget's theories in some modern insights. What are the differences between children and adults? And one of those major differences relates to executive function. So there's an important developmental trend in terms of development of the frontal lobes, which grows very slowly, and children are just limited in their ability to control their actions, to show executive action, executive function, because of that limited frontal lobe or prefrontal cortex development. So first, Jean Piaget, he basically put cognitive developmental psychology on the map. So his contributions occurred in the early 20th century. He was a Swiss philosopher, a natural scientist, and a developmental theorist. He developed many of his insights based on his own 3 children, as shown here, as they were growing up. But he also did experiments involving hundreds and hundreds of kids. And he basically challenged the notion during those early days that children are just mini versions of adults. Early on, people believed that the only difference between a child and an adult is the difference in knowledge. Children just know a little bit less and just feed them knowledge, and then it'll turn into adults. And Piaget objected to this notion. He hypothesized that children not only know less, but they also think differently. That qualitatively, the thinking process of a child just operates in a very different way than the thinking process of an adult. And we'll see his theories that emphasize sort of the quality of reasoning, that children progress through a whole bunch of different stages where the thinking is just different. So one element in Piaget's theories is that he viewed the child as a curious person, as an active learning, somebody who could shape their own learning environment, as opposed to the prevailing notion at that time that children are just passively absorbing knowledge from the environment. And he introduces this notion that infants or children are more like scientists or detectives, where they're constantly exploring the world through physical actions, asking questions, to test their own hypotheses about the physical and social world. So in other words, that children are basically shaping their own development to a large degree. So here's several key concepts from Piaget. The first one is the concept of a schema. Now, we already talked about schemas when we talked about memory research. So we discussed this example of people having a schema of an office, right? when you're processing all the objects for an office, you might use your mental representation or schema or concept of an office that says, what things do you expect to be there? And similarly, schemas from Jean Piaget's perspective are mental representations, right? These are needed to represent things out there in the world. But Piaget also emphasized that schemas include actions. So things that can be touched, things that can be sucked or manipulated, those are very important schemas for an infant that starts to explore the world. Now, how do infants use schemas, and how can they learn these schemas? So Piaget proposed that assimilation is the process where an existing schema is used to understand something, to interpret something, or act something on something in the environment. So if you have a schema for a dog or a rattle, then applying that schema to classify something new as a dog, or like this is a new rattle, that will be the process of assimilation. Now, accommodation is the process where you come up with new schemas, new mental representations, or you make some changes in your existing mental representations because your existing representations weren't rich enough or they contain some errors. So you can think about this process where schemas are used to assimilate objects, or basically categorize objects out there in the world, like is this a dog? So this, when you apply a schema to things out there in the world, that's the process of assimilation. And when you realize that objects don't have an existing schema yet, or there's an error in your schema, then you applied a process of accommodation where you adapt your schemas to new information. And this cycle of assimilation and accommodation is not that different from the scientific cycle. A scientist having some hypotheses about the world to try to interpret the world, and occasionally coming to realization that the hypotheses or theories are not rich enough, and then these need to be accommodated to explain these new observations. And this is very much in line with Piaget thinking about children as scientists. So here's an example of the process of assimilation and accommodation. Suppose you have this child, this 2-year-old Gabriella, looking at picture books and is learning through examples what cows look like. She then develops this mental representation or a schema for cow. Then when she later goes to the zoo and mistakenly says, that's a cow, to a moose, and gets feedback from the mother saying, no, that's actually not a cow, that's a moose. Then, and by the way, so the process of applying a schema to this moose, that's the assimilation process. But then the subsequent process of modifying schemas for cow and introducing a new schema for moose, that's the process of accommodation. So sometimes children need to narrow their mental representations, so not call everything a cow that looks like a cow, and sometimes need to expand their mental representations and realize that some things are called a moose, and that might include like a mommy moose or a baby moose, etc. All right, so one of the main insights from Piaget is the insight that children's development proceeds through a sequence of stages. And he delineated essentially 4 qualitatively different stages. The first stage he called the Sensorimotor Stage. These are roughly the stage that an infant or baby to a 2-year-old infant is involved in. Then the next stage is the pre-operational stage for a 2- to 7-year-old. Concrete operations for a 7- to 12-year-old, and formal operation for children above 12 years of age. Now he wasn't very strict in terms of these age boundaries. Some children, according to his theory, would progress through these stages a little bit more rapidly, some children a little bit more slowly. But he would argue that all children progress through these stages in order, so you can't skip a stage. Note that the word operation is used in 3 of these stages, like pre-operational stage, concrete operation, form operation. And this is a bit old-fashioned terminology, but in his view, operation means logical thinking. So if you're pre-operational, you are not thinking logically yet. The concrete operations child can think logically, but doesn't apply it to sort of abstract scenarios yet. And in formal operations is when the child finally starts to sort of put things together and can reason in a much more abstract way. So the first stage is the sensorimotor stage. This is when the infant is trying to make sense of the visual world, the sensory experiences, and connecting those sensory experiences to physical actions, right? So infants at this stage, they're constantly moving around in their world through crawling and later walking, and they explore a lot. And they're trying to absorb all this information, but according to Piaget, what's quite limited at this stage is the ability to have representational thought. This is the ability to understand that some things can exist even when you don't see them. That you can think about things even when they're not sort of in view. And at the end of this sensorimotor stage, according to Piaget's theory, then these children have some rudimentary form some rudimentary ability to form mental representation. Now, one important notion is the notion of object permanence. He hypothesized that children don't really understand the notion that objects can exist even when they're not in view. So here's this cute little infant looking at the doll or the pet animal and is actively sort of engaged with it. And then curiously, when you put some obstacle so that the pet animal is no longer in view, the infant will quickly lose attention and will sort of not look for the animal anymore. And it seems that the infant just no longer believes that the object is there. So object permanence is the knowledge that objects continue to exist even though you're not acting on sensing them. And he hypothesized that children at this age from 0 to 2 don't have object permanence. Now this is very curious. As from an adult perspective, how can you not know that the object is still there? But I added this slide this morning. I want to show you that even from an adult perspective, sometimes we believe that we have these very rich representations of our visual world, but in reality, our mental representations are quite sparse. Now, some of you have taken the 9A, 11A class, and you've probably seen some of these demos. But let's look at these images. In these images, there's some either some flicker or some other change, and you have to decide what has changed from one frame of the sequence to another frame of the sequence. And many, oh, it has stopped. Let's do it again. That's too bad. Why does it stop? Let's try this one. Here's another demo. So there are 2 frames here, and something is happening from one frame to another frame, and can you detect a change? Now, many of you probably can't see the change. This morning I was looking at it again, and I've seen this image before, and I forgot what the change was. It took me forever to find it. Can people see it? It's the reflection in the water, right over here. Right? So this changed from one frame to the other frame. Here's another one. Very topical, a scene from Paris. You see the change? So this building here is moving location dramatically from one place to another place. Do you see it? And so these demos are called change blindness demos. And the only reason why I wanted to show you is that adults clearly have vastly superior abilities to a young infant, but even our abilities to represent everything in scene is quite limited. In reality, we only keep track of a few objects that are of importance, things we really care about. And all the other details, we just assume that it's all out there. So if those details become important, we can just look at the world. And this is also what a child might be assuming. Most of the important things are in view. So maybe it's not necessary to represent this object sort of independently, because not many things are hidden often in the real world. Okay. Now, at some point, the child does start to discover that things can be hidden and does get a sense of object permanence. And the child now will start to look for things that are hidden under, let's say, a piece of cloth. But then the child makes an interesting and very curious error. So if you start hiding an object frequently in one location, let's say that it's this location here in this particular picture, and the child indeed starts to reach for that location on several trials, but now you change that location to a new location, B. Let's say that's over here. And the child, as you can see in this image, is paying a lot of attention to this new location. And now when you obscure these two trays here, the child makes this error called A not B error. The child will look at the place where this object is hidden, but will grasp with the hand to the previous location where the object was hidden. And so there's some limited object permanence here. And Piaget's view was that object permanence is mostly understood from an action perspective. Things exist and continue to exist only to the degree that they're graspable. So that thing that's hidden there, it's the thing that I could grasp there. And there's just not this limited sort of this limited ability to track objects in new locations. Now, as we'll see later, there's a more modern interpretation of what's going on here, why the child is looking at this new location, but is still grasping for the old location. Now, at some point, kids figure this out, where things are hidden, and that things can be out of view, but they still exist. So they start to develop some representational thought. And they start to develop mental representations for various objects. But according to Piaget, the mental representations are not integrated very well. They're sort of operating independently. And at this age range, you start to see kids focusing on only one dimension of a problem and failing to integrate across multiple dimensions. And so their thought might be somewhat unsystematic or illogical. Another aspect on this pre-operational stage is egocentrism. So children mostly think from their own perspective because even though they might have a sense that different people might have different perspectives, they can only focus on one thing at a time, so their viewpoint is mostly their own viewpoint. So here's one example, a classic Piaget task, where kids have to judge whether quantities are the same or different. So in this experiment, you show two rows of a number of coins, and they're spaced equally, and you ask the child to count these coins, and they duly count the coins, and they can actually count, and they say, this is 5, and then this is 5 as well, and then the experimenter asks, are these the same? This is the same number. And the child will say yes. But now if you start to space out the coins in one of the rows, and you again ask them to count. Count this row, they say 5. Count this row, they say 5 again. And then curiously, if you ask them, is this the same number, they will say different. And this is called the failure to conserve quantity. And according to Piaget, what's happening is that they're paying attention to one dimension of the problem, and the dimension here is width, or basically the spatial distribution of these coins. And they can't sort of combine the number dimension and this size dimension. So I want to show you a video that shows some other demonstrations of the lack of conservation, this limited ability to think about multiple dimensions at a time.
Can you look at these two glasses? Do you think that they have the same amount of juice? You can get the same? Okay. Now we're going to pour this juice into this glass. Now, do you think that this glass has more juice? This glass has more juice? Or do you think that they have the same amount? This one has more, and why do you think that this one has more? Okay, ready? Okay. Does this row have more quarters? Does this row have more quarters? Or do they have the same? They're the same? Okay. Does this row have more quarters? Does this row have more, or do they have the same? That one has the same? Why does this row have more quarters? It's more far away.
So very cute. Now this explanation has been challenged though. So maybe the child does understand number, right? Because the child's actually counting and it counts to 5 in both situations. So why does the child give the incorrect answer of different?
What if they started off with this spaced out first and she counted them and just put it together?
That would be very interesting, yeah.
I feel like she would count. I feel like she's only saying it's bigger because she's asked the same question again.
Exactly, yes. There might be an assumption by the child that asking the same question again should lead to a different answer, right? Because as adults, we have a particular way of teaching children, right? Here's one thing, here's another thing, and the difference, see that? And maybe the child is just assuming that it has to be different. Why would they ask the same question again then, right? And what you said, I don't know what the outcome of an experiment would be if you start with this display, right? Would they say same? I'm not sure. Okay, another issue related to the problem of interrelating multiple representations, the phenomenon of egocentrism. So Piaget noticed that his own children, had difficulty reasoning from other people's perspective. And he developed this mountain task. So he grew up in the Swiss Alps, so thinking about mountains is something very natural there, where you see 3 mountains on a table, and the child is sitting on one side, and they have to say they have to match their view to some picture that they see, and then they have to reason about the perspective from another agent, in this case a doll that might be looking at the mountains in a slightly different way. So here's a demonstration of this egocentrism.
The same, that's right. Now, if I put the dummy over here, right, over there, which picture now shows what dummy can see? Well, so you point to the one, point to the card, and picture the card. That's it? Okay.
Right, so curious, right? Why can't they realize it should be a different perspective? So this is what Piaget called egocentrism. Now so egocentrism relates to a very specific problem of reasoning about visual perspectives. But this issue is much, much bigger because this extends to also social cognition, reasoning about what other people believe, what they need, what their desires are. And young children, they have severe limitations in terms of understanding that the child's own beliefs might not be shared with everybody in the world. There's a difficulty of separating your own mental representation, what you know about the world, with what other people know from their perspective, from their backgrounds. And one of the classic tasks to show this is called the false belief task. And so it's a bit of a convoluted setup where the child sees a play of characters with some toy animals or some people, and then the child is watching the whole story unfold, and the child has full information. But some of the characters in the story don't have full information because some of the characters leave and then come back. And then the question is, do children understand that what the agent, the character in the story knows is different from what they know? And that's what's called a false belief task. So I want to show you a longer clip with 3 demonstrations of false beliefs where children don't quite understand that what they knew before might be different than what they know now. That is an inability to reflect on your own knowledge and changes in knowledge. It has one demonstration of false belief task, and the third one, well, we'll just play this clip, and it's a bit of a longer clip, 7 minutes long.
Box. What's in the box?
Cheese.
Look at that. What are they? Jacob calls the ribbons ropes, which is fine because it's the next question that counts. What do you think was inside the box before I turned it over? It's surprising. When you think, well, surely they can remember, they just said juice a moment ago. It's really surprising when they say that they thought there were ribbons in there. And you realise that they just don't think about the world in the same way that we do. Okay, sorry. Not only is Jacob now convinced he always thought there were ropes in the box, he also believes if he thinks something, so must everyone else. Jessie hasn't seen inside this box. What would Jessie think is inside before I turn it over? The innocence of the 3-year-old mind is both wonderful and a little spooky. And it's led Toronto's Tom Keenan and David Olson to
to play an elaborate game to find out if young children understand deception. One of the players is 3-year-old Ross.
This is John. This is his big sister Katie. And that's John's mother, John and Katie's mother. And I want you to pretend that they're real people just like you and me, okay? Now look at John. John has big feet. And Katie has little feet. Now watch what happens when they walk through the flower. They make footprints. Okay. See the footprints they make? Now, can you tell me which footprints are John's footprints? Which ones did he make? That's right, those are John's footprints. Okay, now can you point to Katie's footprints? Which ones did Katie make? Very good. Okay, now, what we're going to do is I'm going to tell you a little story about Katie and John. I just have to take your shoes
The
off.
story takes place in the family's kitchen. Mom spilled flour all over the floor while baking the muffins that John and Katie now can't wait to eat.
So they asked Mom if they can have some muffins. But Mom says you can't have muffins right now, dinner's almost ready. So Katie and John go back to their bedroom. Now, Mom hears the phone ring. So she goes downstairs to answer the phone. And when she's downstairs, she can't see us and she can't hear us, okay? Okay, now, you know what Katie does? Katie decides she's going to take some muffins. So here comes Katie. But before she takes the muffins, she puts on John's great big shoes.
Tom spells out for Ross exactly why Katie switches shoes.
So here goes Katie. She put on John's shoes. She'll show me big footprints in the flour. And so that the mom will think John took the muffins. Okay? So here she goes. Katie grabs the muffins. She eats them all up. Now, Katie hears her mother coming back. So she runs off to the bedroom. And here comes Mom. Now Mom sees that the muffins are all gone. And Mom also sees the big footprints in the flour. Now, can you tell me who ate the muffins? Which one ate the muffins? Was it Katie or was it John? Right. Did Mom see Katie eat the muffins? No, she didn't, did she? Okay, now are there big or little footprints in the flour? Are those the big ones or the little ones?
Big ones.
They're the big ones, okay.
The red top.
Okay, so who will Mom think ate the muffins? Will she think it was Katie or will she think it was John? Okay.
Despite apparently following the logic of the story every step of the way, Ross still can't see that Mom doesn't know what he knows. This belief that thoughts in your head are somehow public knowledge, that what you think everyone thinks, is almost the definition of childish innocence. Watch this wonderful example with psychologist Joan testing 3-year-old Jacob.
You're going to choose one of the stickers, and he's going to choose one of the stickers. But he always chooses first, and he always wants the one that you really want. He doesn't care if you're sad. Let's remember with another thing, that he doesn't know which sticker you really want. You tell me, which sticker do you really like? Which sticker do you not want? Okay, now I'm going to bring back me and Monkey, and he's going to choose first. Remember, he always wants the sticker that you really want. He doesn't care if you're sad. So think of what you can do or say so that he doesn't get the one that you really want. There comes me, Monkey. Which sticker am I going to choose? Jacob, which sticker do you really want? No, I'm going to take this one, so you get to take this one.
Joan repeats the experiment several times with each child, giving them ample opportunity to deceive the monkey as to what they really want.
Tell me which sticker you really like. That one. And which sticker do you not want? That one. Okay. Jacob, which sticker are you going to take? I'm going to take that one. You
Bravely accepting 3-year-old Jacob never figures out that the monkey can be fooled. older, and already with a knowing gleam in his eyes.
And which subject do you really like, which is the greatest? That one. Okay. With those sticks there, I'm going to bring in new ranking. Let me see which one I want. Patrick, which one do you really like? Oh, well, then I'm going to take that one, and you get to have that one.
Yeah, it's pretty cute. So any comments on those clips? So it was the second one where the false belief task, right? Where the child has to reason about this, the mom and John and who knows what. That's when you see these limited abilities to take a different perspective, a limited theory of mind. Okay, so we talked about some of the really classic findings in Piaget's research. And many of his experimental findings, they're not called into question. So he basically put all these interesting phenomena on the map for other people to think about. And he developed these theories of, based on stage theory. And a lot of researchers are questioning the underlying sort of theory, Piaget's theory. We now know through all kinds of experiments that children are much more clever than Piaget gave them credit for. And we notice by doing these habituation experiments that people can discriminate between a lot of things before they can verbalize their knowledge very well. It's also called into question whether there are any such things as discrete theories, discrete stages. A lot of people think that maybe just getting more knowledge is important, building up experience and expertise, and that basically development is continuous. It looks like it's qualitatively changing, but it's really all continuous. So recent research has shown that even very, very young infants, they have a pretty rich understanding of the physical world. It could even be that it's innate, our understanding, basic rudimentary understanding of the physical world, and that even very young infants understand object permanence. And then very importantly, people started to look at the development of various areas of the brain and emphasized the development of executive control processes as the explanation for developmental changes. So this is one illustration that's also shown in the book. If infants are looking at this display, then according to Piaget, the things that are hidden from view, so the parts of this woman's leg, should not exist. Or at least that's a naive, sort of simple interpretation of Piaget's theory. But as it turns out, infants will be very surprised to see this display followed as opposed to this display. And so why could they be surprised? Well, they have an understanding of object permanence in a sense, that there are things that can be hidden from view and they continue to exist. So this is a very strange explanation or very strange continuation of the original display. Similarly, here in this demonstration, if you have a moving rod that's partially obscured by this block, then children, again, this naive interpretation of Piaget's theory would say, well, children assume that what's behind the rod does not exist, and so they should not be surprised to see this display, where you have two disconnected rods moving simultaneously behind this block. But they are, in fact, very surprised to see this. So adults and children alike would be very surprised to see this sort of surprising coincidence of these two separate rods moving in concert. And you can get at this by inspecting looking times and habituation, right? So if children habituate to this display, they will look longer at this display because it's new and novel and surprising. And so there's a lot of interesting research on what children find surprising because it reveals what they already know about the world. And this is quite amazing research that shows that even a 3-month-old infant knows a lot about the physical world and knows what things cannot possibly occur, what things are magical events. So I want to show you this clip.
Renee's group puts on magic shows for babies, with results that have astonished her colleagues around the world. Each show tests whether babies know some basic physical rule, that objects can't just disappear, for example.
If babies have the knowledge, they will be puzzled or surprised or intrigued by our magical events. And you know when babies are surprised or puzzled, they tend to scrutinize the events, to look and look and look at them. And so what we do in our experiments is compare infants' responses to magical events and non-magical or real events to see whether they look longer at the magical than at the real ones.
As Holly's attention is captured, a hidden observer starts the timer. This time it's a non-magical normal event. The 3-month-old is soon bored. She looks away, and the clock is stopped. Now for the impossible magical event. Holly stares. She really scrutinizes the event. That means she's surprised. Even at 3 months, she knows the world doesn't work this way. Backstage, there's a simple explanation. 2 dolls moved independently. But Holly is bored, and even startled by such an illogical sight.
So think about it. So a 3-month-old can understand that this is magic. A 2-week-old baby cannot, by the way. They've tested as young as 2 weeks, and they do not sort of see the difference very much. Maybe they don't even see the whole display very well. But this understanding comes very early, and this raises questions of, is this learned? Is this innate, this ability to detect magical events? What's physically possible and what's not? The other challenge to Piaget's theories is interpretation of the egocentrism finding. So the 3-mountain task was kind of complicated. If you have to reason about the visual perspective, if you look at the mountains in a slightly different way, and it's kind of complicated if you don't grow up around mountains. And what researchers have shown is that if you simplify the display, but also put it in terms that the child can understand, in terms of trying to hide from somebody, then children have no problem taking somebody else's perspective. So if you have this display and you have a policeman that looks out in this direction, and then you have to place a little robber that should not be found by the policeman, the child has no problem putting the robber in A or C, away from the viewpoint of the policeman. And it shows that children actually can take different perspectives, as long as the task is sort of concrete and something familiar to them. I'll skip this little video. So that's another challenge. And then finally, the biggest change in how we think about cognitive development comes from cognitive neuroscience. So clearly the brain is developing over time, but one of the areas that develops the slowest are the frontal lobes. And the foremost part of the frontal lobe, called the prefrontal cortex, takes many, many years to fully develop. In fact, it's up to 20 years of age before your prefrontal cortex is well developed. And the prefrontal cortex is assumed to be involved in executive control, controlling your actions, controlling what you pay attention to. And it is thought to be necessary to override impulses, to override various automatic responses. So perhaps one explanation for of a child that fails to conserve quantity is maybe they look at the two rows of coins and they focus their attention on the size aspect of the dimension, and they fully realize they just have counted them, right? So they realize they're both 5, but they can't sort of override the sort of the thing that's in view the most, the size dimension. So maybe it's just a problem of executive control, of overriding some initial impulses. Similarly, maybe problems of theory of mind are related to a failure to switch from one representation to another representation. Most of the times, reasoning from your own perspective just makes a lot of sense. And maybe you just need to override an impulse to reason from your own thoughts and beliefs. I'll skip this one as well. Now the one classic demonstration that shows the problem of impulse control in kids is the Marshmallow Test. It's one of the most famous experiments in psychology. And this really tests your ability to not go for immediate rewards, but to delay your impulses so you can get a bigger reward later on. So these experiments test your ability to delay gratification. And Walter Mischel, he argues that this is a big difference between children and adults. But he also argues this is a big difference between kids. Some kids, they have a better ability to delay gratification. So in this experiment, the child is offered a choice. They're sitting in front of a table, and you'll see in the video next. They see one marshmallow. If they ring the bell now, they can get that marshmallow and eat it, which is good. Or they can wait, and the experimenter does not say how long they have to wait, and they can get 2 marshmallows when the experimenter returns. And the question is, what does the child do? Does the child resist the temptation to immediately grab that marshmallow, ring the bell immediately, or can they wait for some unspecified amount of time? So let's watch this final clip. Yeah.
It's called the Marshmallow Test. We try to set up situations in which young children make a choice between 2 of something that you prefer later or 1 of something that you prefer less now.
If you had to choose, would you like to have 1 marshmallow or would you like to have 2 marshmallows?
The whole point of the experiment is to set up an intense conflict between the 2.
Now here's how we play this game. I'm going to leave the room while I'm gone. If you can stay here and wait for me to come back. Without eating the marshmallows, then you get 2 marshmallows. But if you don't want to wait, you can make me come back right away by pressing the bell. But then you get 1 marshmallow, not 2 marshmallows.
I will ring the bell.
You won't ring the bell? Okay.
The conflict for the child is very heavy. Is that about half will go one way and half will go the other.
Oh, you made me get back.
It's like a little window into willpower, or dilemmas that everybody faces. A very simple and direct way of measuring the confidence that seems to make an important life difference. The longer they were able to wait at age 4, the better the ratings of their ability to control themselves or to pursue their academic and other goals. middle-class, those less drug use, higher educational level, can be much less likely to have lower self-esteem, to engage in bullying behavior with other people. Correlations are clearly statistically significant, but that in no way means that a youngster who at age 4 didn't wait a long time is in any way doing.
Right, so there's some funny variants of this on YouTube. One has a child hollowing out a marshmallow and then putting it back and then trying to fool the experimenter. So the finding is that some kids go immediately for the treat. About a third in his experiments were able to wait the entire 15 minutes, which could be a very long time for these children. But the critical part of the experiment was the longitudinal element. So these kids were tracked over a long period of time, and then what the researchers found is that the children who were able to wait 15 minutes, they tended to have better adjusted social lives, tended to have more friendships, they did better in school, they had better SAT tests, were less likely to do drugs or end up in prison. And so it seems that this very simple marshmallow test can predict later behavior to a large extent. And there's been several replications of this experiment, and the findings have mostly been held up, but the interpretation maybe has changed a little bit. So the original interpretation is a little bit like that there's a failure of impulse control, right? But maybe part of the explanation is about whether the child believes that the experimenter will come back. Children that are raised in less fortunate circumstances, more unstable environments, they might have learned over time that the parent might not be as reliable in all circumstances. So maybe a good thing to do is eat that marshmallow now, because the marshmallow you can eat now is something, that's in the bag. So they've done some follow-up experiments where they randomly assign kids to different conditions. In one condition, the stable condition, the experimenter does what he or she promises to do. In the unstable condition, the experimenter basically reneges on some promises. And then they're transferred, these kids, to another experiment, a marshmallow experiment. And what they find is that the kids that have learned that adults sometimes don't do things, that are sometimes not reliable, they eat the marshmallow immediately. So the explanation, the alternative explanation is that, well, maybe it's about what kids believe will happen next. And maybe some of these kids could also be just very hungry, and if you're hungry, it makes sense to eat that marshmallow now. So that's it for today, and I'll see you guys next week, and happy Thanksgiving.